Alright, in this video I'm going to show you how to solve some exponential equations. And the method I'm going to use for this one is going to be called the rebasing method, and you'll see why, hopefully. So there's a lot of different types of exponential equations that you'll see. You won't always be able to use this method, but when it's in a particular form you will. Alright, so we're going to use this fact. It says that if a to the power of u equals a to the power of v, so a and a are the same, that must mean that u equals v. Okay, so we're going to use that fact. Okay, so a would be our base, and so that's kind of where the rebasing term comes from. We're basically just going to set the exponents equal to each other once they're in that form. Alright, let's see if it'll focus now. Alright, cool. So let's start off with this example over here for a. This actually comes straight out of your textbook. So I'm just doing the example problems there. So what we're going to do to solve this, this is not in this form, a and a, right? 3 is certainly not 81. But I can rewrite 81 as a power of 3, turns out. So 3 to what power is 81? Turns out 3 squared is 9, 3 to the third power would be 27, and then 3 to the fourth power is 81. So we can rewrite 81 as 3 to the fourth power, because 81 is 3 to the fourth power. And this side is going to stay the same. So now we've got our equation set up where we have it in this form, where the bases are 3 and they're the same. So then we can use this fact. Since these two are equal, then we can just set the exponents equal, and we can ignore the 3's now. We don't need the 3's. We just set those exponents equal to one another and solve for x. You're welcome to verify this, right? You can plug this back in. 3 plus 1 is 4. 3 to the fourth power is 81, so we do know that is correct. And let's do another example, because they do get a little bit more complicated, and you'll see the laws of exponents come into play here. So this one's different, right? Because you might think, okay, I'm going to rewrite 8 as 4 to a power. Well, 4 to what power is 8? It doesn't work, right? It doesn't come out evenly. So what we're going to do is we're going to rebase both of them. We're going to rebase both. So I do know that I can rewrite 4 as 2 squared. So I'm going to do that. 2 squared is just that 4. And that whole thing, that is 4. Now that has the exponent of 2x minus 1. And we'll deal with that in a sec. Okay, so be careful when you're solving that in that way. Alright, so then this one, we're going to rewrite as a power of 2. That's actually going to be 2 to the third power. And that has an exponent of x plus 3. Okay, so now we need to know a little bit about the laws of exponents. So what the law says that if you have a power, like 2 is our power 1, 2, and it's raised to a power to a power, you actually multiply these. And so I'm multiplying this 2 times this 2x minus 1, which will give me still the base 2 to the power of 4x. Remember, I got to multiply times the negative 1 as well, so 4x minus 2. Same thing applies here. I have a power to a power. Okay, so that's going to be 2 to the power of 3x plus 9. Alright, so the laws of exponents way back from Algebra 1, 2, maybe Algebra 3, 4. Now that I have it in this form that I wanted, I can get rid of the bases. So I've rebased it already, and now I can set the exponents equal to one another. Alright. So now I can solve for x. I'm going to move these 3x's over. It's going to give me x minus 2 equals 9. So if I subtracted 3x from both sides, that would go away. Add 2 and you get 11. Okay. Now you might be thinking, well, what happens if you can't rewrite it as a power? And that's where you'll need some other tricks. But if you can, this is kind of the easier way to do it. Alright. So last one, okay. The letter E is what we're using here as our base. Okay, so remember E is one of those special numbers in mathematics, kind of like pi. So it's just a plain old number. It's not another variable. So this is an actual number. You can type it in your calculator if you'd like. I'm going to do the same process. It looks like we have a bunch of bases of E, but I need to get it one base of E to a power and one base of E to a power on either side of the equal sign. So this one is already like that, so I'm just going to rewrite that. We're good to go there. And this one needs some work. So we've got another power to a power, so this is going to be e to the power of, that's x times 2, so 2x. And that's multiplied times 1 over e to the power of 3. Now, I don't know if you remember, but when you multiply fractions, you just multiply the numerator times the numerator, denominator times the denominator. The denominator of e here would be 1, so this is multiplied times the 1 here, giving me e to the power of 2x over e to the third power. You may have seen that already. You may already know that. Okay, I'm going to keep on going, and I'm going to get, let's see if I can scooch my camera, and let's see, so again, the laws of exponents here say that I have to subtract these exponents. So I'm going to get e to the power of 2x minus 3. That is a law of exponents. As an aside, if you forgot what that is, imagine I had x to the 7th power divided by x to the 3rd power. That's going to equal x to the 4th power. Why is it x to the 4th power? There's 7 here, there's 3 here. 3 of these would cancel, leaving me with 4 left, or the rule says subtract the exponents, you get the right answer. We're going to do the same thing here, what we already did. So e to the power of 2x divided by e to the 3rd power. The law says subtract the exponents in that way, in that direction. Numerator minus the denominator. All right. And so last steps, we can now get rid of the base. All right. And we are going to solve for x now. So I'm going to add x squared to both sides. You get this. I can factor that. And use the zero product property, giving me my two answers, -3 and 1. And that's how you do it. There is a more difficult type as well we'll have to come back to.